So this is lesson 21. In this lesson we'll be talking about the FIFO. First in, first out is part of the memory which we spoke about in the last tutorial that we'll be accessing for storing our receive and for data we would like to send. So we can find the verilog code at projectfpga.com/tcp. Select the Wishbone FIFO. First in, first out. This is the code. I'll be explaining it with the logisim in logisim actually. So what's this FIFO all about? Just like the RAM reads and writes, but it has a little exception, but I'll show you by demonstration. So what it does, so this upper layer does the status. It gives the status, that is whether it's almost full, almost empty, and empty. So that's what this upper part does. Then, so that I'll be able to explain them section by section, this is used for reading. They are all counter. This is used for reading. This is the adder which does the counting, but this section is for reading. Here is used for writing, and this is the FIFO storage. This particular lower layer are the FIFO storage. So what does this FIFO storage entails? So the size is irrespective of the size, because I customize the size based on my design in logisim, but on the code they give space for adjusting the size also. So what does it do? So remember in our SPRAM, our data out. So whenever data comes in here, is ready to write or read, then these are the three signals that are used, that serves as input to this write. So let's treat this, the write section and the read section, independently and see how they all work. So let's start with the write. So this section does the write. So let's see how does this FIFO write and how the FIFO reads. So first of all, here there's no address. It reads by counting. It reads it serially, line by line. It keeps reading. So first of all, this signal here does the reset function. This signal here, clear, whenever you clear, that does the reset function. But this second multiplexer here selects whether you want to read or whether you want to write or you don't want to write. So let's see what actually turns that multiplexer on. So this is where the multiplexer turns on. So this AND gate here says 1, you must select the right input, right signal, and 2, this signal must be off, full. The RAM must not be full, that is the memory size must not be full. So let's simulate and see. Now the memory is not full, so whenever we select write, it starts counting. This adder starts counting. It's counting and incrementing this RAM here, and now the output from this RAM is fed to this demultiplexer. So you can see this is a demultiplexer that receives the output of this RAM. So what this demultiplexer does is that the RAM, this right RAM is a counter. It keeps incrementing, and whenever it's incrementing, it's selecting different parts of this demultiplexer, and this demultiplexer goes into each of these RAMs. There are almost 8 of them. It goes into every single one of the RAM. So whichever one is selected, a high signal is sent into it. This is a 1. A high signal is sent into that particular memory storage. So let's see what it entails to write. So to write, you turn on this multiplexer, and this multiplexer is controlled by this 3 input AND gate. So what are the conditions for turning them on? One says this signal must be off, and it's connected to all of them. Let's go back and see what signal it is. Still that full signal, it must not be full. For you to write, it has to be empty or almost empty. You can't write in a memory storage that is full. Then the second signal, this must be on, which is the right signal must be selected. That is, the right signal must be selected. And last but not the least, that is, this is used to select the individual RAM. So this last one says the multiplexer input must be 1. So this is exactly what it does. We can see that the first two conditions here, which is it must not be empty and the right signal must be selected, is common to every single RAM here. It's common to all the RAM except this last one, which is the demultiplexer on signal, which is what actually makes a choice. It chooses which of the RAM is going to turn on. So while the counter is incrementing, we can see that it loops through all this RAM and writes to every single one of them. So this data is not a static data. It comes per clock cycle and is being written to every single RAM one after the other. Every single RAM one after the other, it writes to them. So that's basically what this FIFO does. It writes to every single one of this RAM is being written to. And now let's see how it does the read. This is the part of the read. The read has almost the same algorithm as what we just saw now. So first you use the clear signal to reset. Yes. Now you likewise use this AND gate to turn it on. So it says, the AND gate says the read must be selected and it must not be empty. So you don't read the one that is empty. So if this case is met, it starts incrementing and the output is fed to this multiplexer here. The output is fed to this multiplexer here, and the multiplexer, once it's counting, is looping, going line to line, choosing every single one of this memory storage and outputs them. It outputs every single one of them and sends them as output. So that is that. So whenever you clear also, it goes and selects the data in, because once you clear, is assumed you are starting from the beginning to read or to write. So the first beginning is the data in itself. So that is what this last multiplexer here does. So why we use this FIFO is so that in case we are receiving data faster than we are storing them, the FIFO actually stores them before they are moved into the RAM. The FIFO acts as a temporary storage, trying to make sure that it's not being bogged up. So that is the major duty of the FIFO. So let's see this upper part and see what it does. So likewise, there's another counter here. So this is where it's stored. So whenever it counts and is full, it counts from 0 to the highest. Once the RAM full, it reaches almost full. See, you can see the counter incrementing here, and whenever it's equal to the highest, it says full, and this stops it from writing. It says it's full. Then we also have the almost empty and the empty. So that is basically how this FIFO works. It helps as a temporary storage, and it means first in, first out. The first to be stored will be the first to be read, but it stores them and enables our memory to access them when it wants to access them. So that is the major function of this FIFO. So this, aside from even the earth mark, we can still use this FIFO for our own customized design. It's very nice when you are working with peripherals that sends data to probably the CPU. The data can be stored in a FIFO, and whenever the CPU is less busy, it can start attending to each and every one of the data. So if you go through the code with my little explanation, hopefully you will understand this circuit. Thank you and subscribe to my channel.